Hello everyone. Welcome to the stream. Today we're going to be doing technical interviews part 2. So this is a 3-part series. We did part 1, which did a lot of just Q&As, as well as going a lot of the basics into technical interviews, what to expect, some experiences. For part 2, we have some prep. Make sure to check in. I'm going to drop the check-in link into chat. Then we will be having our part 3 later today, actually. Doing some actual coding practices live. Let me see. Okay, cool. So everything's been dropped into chat. The check-in link, make sure you check in. I'm going to restart the music on lower sound. We'll get going. Okay, cool. Make sure you check in. Okay, cool. I'm going to drop it one more time. Then let me actually edit this banner. I'm going to hide that for now. This banner. I need to get a shorter link for those. That's okay for now. Let me know if you make sure you guys can hear me. If you can't hear me, please let me know in chat. If the music's too loud, let me know in chat. I do like to keep a bit of music running as we go through this stuff, but just let me know. Okay, cool. So as a quick introduction, I'm Kev. So I'm a coach at Major League Hacking. I use the he, him, his pronouns. I do a lot of different things. So honestly, feel free to talk to me about anything. Then let me just make sure my audio. Yes, it's here. Okay, cool. So today on the schedule, we're going to be going on the schedule review. So we already did technical interview breakdown, which was part 1, which ended already. Today we're going to be doing technical interview showcase and example, which is part 2. We're going to go over STAR, the interview technique, practice questions and answers for STAR, exploring some of the coding interview IDEs, exploring coding interviews do's and don'ts, and the best coding interview practices in time. Sometimes complexity problems, because I know that's during part 1 of the. Okay, cool. Actually, before we get started, we're going to drop the check-in link one more. So as the chat, have enough. Oh, don't know what occurred right there. Let's see. Okay, cool. So let me move this up. Feel free to ask me any questions in chat as we go along. But first, we're going to go do an overview of what STAR is. So let's get going. Oops. Okay, so STAR. STAR stands for Situation, Task, Action, Result, Reflect. I know the other one said STAR. The more common one is just Situation, Task, Action, Result. I saw this one reflect on it and I kind of liked it, so I tossed it in. So it started with 2 hours now. Hello, welcome to the stream. We're doing our technical coding interview part 2, and we are going over STAR interview. Okay, cool. So with that being said, STAR, or S, stands for situation. So this technique is really used when you're asked more behavioral questions. So like, what would you do? How are you handle something? And this is really important how you go about it, because STAR allows you to try to tell a story, but as you're telling the story, hit every major point as you go along. So S stands for situation, which situation is describe a situation or problem that you have encountered. The person you're talking to or your interviewer understands what the issue is or what you were trying to solve. Tasks. Describe the task that the system required and why it's important. So this one's really important because you're really breaking it down for the interviewer, right? So you first told them what the problem is, then you told them what are the tasks to help you achieve a solution to that situation or that problem. Action. Describe what action you took or the obstacles you had to overcome to complete those tasks, which then satisfy the solution or resolve the situation. Result, which is from your actions that did the task in the situation, what were the outcomes? Highlight the outcomes and what you have achieved and how success was measured. Reflect is just, I like to tag this along just towards the end of it. It just explain what you've learned from it, right? So it's kind of like when you're writing something towards the end, you give it a reflection. This is actually really important in teaching philosophies and stuff that has to do with teaching in STEM as well, is reflecting on your work, even within, let's say, when you're writing a paper or work you're already completing. So for example, we're going to do some sample questions. If you have any questions on STAR, feel free to drop them in chat. But for example, a situation I would start would be like, so in my operating systems class, I had to build a replica of a kernel or a replica of a shell. And I had to do this in kernel space. Task. So the first thing I really had to do was figure out what shell were we looking at. So we were looking to mock the GNU shell, bash shell, etc. Action. So what I first did was I took a look at all the functionalities that existed already in a bash shell, then started writing them down, mimicking them down, and then I went and coded it in user space in Python, and then went and coded it into kernel space for the shell. And then after that's all done, I packaged it and made it made my Linux user point out to that default shell. So I described the situation, task, and action. Result. At the end of the day, I was able to allow the computer to directly access my custom shell, which is based off of the bash shell, and I submitted that for my project and did well. I think I learned a lot from that experience. I figured out how to work in kernel space, how to take user space code, convert it to kernel space code, how to make system calls, etc. Right? So I gave a situation, I talked about the task, I talked about the action, I talked about the results, and I reflected on what I learned. So doing all this, put together a whole story, and make sure you don't leave out things, especially when you're nervous, and leave your interviewer confused. Whoop. Next slide. So some practice questions that I'm going to do right on stream right now. Feel free to stop me at any moment. One of the more common questions you might get are questions such as, what is the project you are most proud of, and how did you contribute to it, right? So let's dissect this question down real quick. So the first thing is, what is the project you're most proud of, right? You want to tailor this to the interview, your interview you're going for, right? So if you're going for more of a data science role, it doesn't have to be the sole project you're most proud of. You can pick a project that you're most proud of that you've done in that field. If you don't have one, let's say you don't have a data science project, pick something that's close to it, right? For example, let's say a web scraping search engine, or you use web scraping to collect data somewhere to build something, or they even have to be in technically computer science, right? So if you're going for a data science role, maybe take something from statistics. If you have taken a statistics course and worked on project something, how did you contribute to it, right? So you can talk about, if you take a team project, make sure to highlight what you've done specifically for that project. If you picked a solo project, highlight what actions and tasks you've done to get to your result to resolve that situation, right? So for example, what is a project you're most proud of? A project that I am most proud of was I built this React application that allowed that was used for a business purpose to collect information from a subset of users to streamline our already existing process. So then let's go back, right? So our tasks. So the first thing I had to do was it was actually my first time using React, so I learned how to use React. I broken down what the business required and needed. And from there, I defined my criteria. And then how do I contribute to it? I wrote the front end UI for it. I did back end work for it, etc. Do you prefer to work alone or in team? This is actually a really common one, especially in computer science, is when they ask you, do you prefer to work alone or in team? I think you should really be honest about this, but be aware of what you say. So my answer generally to a question like this, just lowering the music a bit. So my answer to a question like this would generally be along the lines of, I really enjoy working with team and coming back to the team for feedback, but I also enjoy working alone with individual time to actually flesh out my idea and then come together as a team to get feedback. So it works through this revision process, and I'm allowed to use my creativity and freedom to explore a problem and then pitch it to the team for criticism, and then go from there and continue to revise what I have worked on, right? So you incorporate both a team component, a solo component, and why it's important that those both exist and why they're important for you. You can also totally just answer, I prefer to work on a team because XYZ, or I prefer to work alone because XYZ. But generally, I think it's always best to highlight that you are able to work in both scenarios, especially in tech, because there's a lot of times where you will be working alone, but there's also equally a lot of times where you will be working together or required to work together, especially on like big code bases. The next question. How would you overcome the challenge of working with a difficult coworker on a team project? Conflict is one of the things that a lot of companies like to ask about, solely because conflict is up, Foster. Thanks for joining us. We're going over practice problems with the STAR method. So conflict is a really key one, because most people, well, most interviewers, they're really trying. There's no right answer per se, but they're really looking for is the answer that addresses the conflict, but doesn't get. It's a sort of manner of addressing a conflict that doesn't get conflict. There are times where it can't get confrontation. It's really just gauge how you think, what is your logic, what's your next course of action, if it really fits with the culture there, right? So like, how would you overcome trying to work with a full team, co-worker on a team project, right? Maybe you can try to build in systems to help them hold them more accountable, right? So like maybe you do early. So how do you overcome a challenge working with a difficult? I might talk to them about it, see if we can resolve the issue. I might build in systems for them, right? So like maybe I would meet with them every morning, make sure they know what they're doing. I would check in on them, right? So like, how would you handle that situation? So if I was asked that question, how would you overcome the challenge of working with a difficult coworker on a team project? Again, go back to the STAR method, right? So you can always tell a story. Oh, oops, I go forward. So for example, situation. So I would normally talk to my coworker and figure out if everything is okay, figure out, see what they might need help on, maybe check in on them more often to make sure we're going to meet our goal and criteria. Example of me doing this would be, I used to run a student organization where there might be sometimes conflict or difficult working with a certain person because maybe their schoolwork has picked up. So what I would do, I just described the situation. What I would do is I would set out and communicate with them more, check in with them on daily to see if they need help with anything and to see if how can I help them move along in the process. Action. So for that, I did that for maybe a week or two until they really got over their schoolwork and make sure they're all caught up. Result, we end up making sure everything got taken care of and done. Reflection, I think we might just start building in more of these systems to our day-to-day task or our day-to-day flow, right? So that was the example where I answered the initial question, tied in a story with it to give example of I have applied that type of method. And then another final question, what do you do to stay up to date on your Tenko certification knowledge? This is a really, really common one, especially if you're interviewing for an entry-level job that is not entry-level. So hear me out. So there's a lot of jobs out there where they are entry level, but they're not entry level at the exact same time. Which in terms of like they're entry level, but their entry level skill set's a lot more higher. I typically find this in like a lot of cybersecurity roles because you do have to know a lot to be proficient in cybersecurity, right? Because you're going to be the person that has to analyze the whole system. That includes like the front end stuff, the back end stuff, how software works, infrastructure, engineering. Like you really need to know your stuff. So like, or like if you are going for a really niche type of role for like data science or like blockchain roles, they might ask you stuff like this to see how you stay up to date to the news, right? It's almost like if you were a finance major, they'll ask like, oh, so what's going on in the market today? They would ask, okay, so have you heard of the recent vulnerability for cybersecurity? Have you seen a new method for thing in like, I don't know, AI, machine learning, right? So it's like in these niche fields, they will ask you, how do you usually keep up to date? Or what is the newest thing you have seen? And you want to be able to answer those questions, but I answer them honestly, right? Because if you set your expectation up really high, that you do something you don't, that can get really tricky going down the line. So if you answer these questions, I would answer them honestly. You can say, I have been busy with school, haven't really been able to keep up with things, but when I did keep up with things, I saw XYZ. Or in school, I looked at XYZ. So like, how do I stay? So if I was asked this question, how would you, what would you do to stay up to date on your technical education and knowledge? So for me, I really am currently in school, so I do a lot of my training through school. But outside of school, I really am curious about different topics in cybersecurity. This is a cybersecurity role, but I'm curious about a lot of topics in cybersecurity. So I enjoy a lot. I join a lot of extracurricular stuff in cyber. So I'm part of our school cybersecurity team, which we do like competition, analyze systems, to look at recent vulnerabilities. So for some of the ones we have looked at, maybe like the Log4j, XYZ, right? So take an answer and then like, for example, recently I competed in a red team, blue team competition and placed second place. And I learned a lot through that competition. So during the competition, I was on the blue team. I had to defend a system from attacks from the red team. I learned a lot about window hardening. And then I took away XYZ. So follow the same STAR method. First answer their question, historian. But you also, when you do something like this, still got to be mindful of time. Time is probably the hardest thing. Is you got to respect your interviewer's time, because again, I said this in our last stream, was that a lot of these interviewers, they all volunteer their time throughout the day. They're generally your standard average dev or maybe team leads from these teams. So they're really volunteering their time. So we generally have to be respectful of that, and that goes along with it. Okay, so now we know practice question. Let's do some exploring of coding interview IDEs. I am going to temporarily block my stream for a second to just make sure. So like, streaming is great, but being security conscious in streaming, it's not so great. I'm always scared that I will leak with dock myself. So you're gonna, I don't know what this is. Oh, I did not see that. Okay, cool. So we're gonna throw up this screen for a second as I just make sure everything is ready for you guys to look at. And we are not gonna explode. Okay, cool. So we're good. So welcome to a few actual examples of actual coding challenge IDE. These are two of the most popular ones I've always seen company uses. Some companies don't. Some companies might legitimately hop on a call with you and pull up a Google Doc. I know Google does this. They legitimately put up Google Doc. I think they have an edited version of Google Doc where like it does some sort of code completion and It's like an internal tool they use for assessments. But a lot of companies uses two of the most popular one, which is CodeSignal and HackerRank. These are coding assessment platforms. Two of the most popular ones I've seen by far. There are some like tinier ones out there, but those I haven't seen as much or I rarely see. And then for let's say some company just legit will hop in if it's in person, they might whiteboard it out with you. They might pull up one of these or an actual IDE and do it. But these are for like your virtual online assessment. These are the most common ones. So this is CodeSignal. So we're really just going to explore the IDE, how it works, and really go from there, right? So this is a pretty easy example. But first things first is make sure you're comfortable with these IDEs. This is why we're exploring them. that was fun. I never had to block someone before. That was a first. I'm gonna double check that block actually went through. I've never had to block someone. That was definitely interesting. Okay, cool. Back to what we're talking about. I'm actually gonna turn off. So really key into this when you're taking a testing assessment. Taking a testing assessment. My first time doing it, I never been on any of these platforms. I also got a OA or online assessment from a huge company, a FANG company, and like I have never written. I've never done the online assessment before. I've never even taken any practice for online assessment or coding view assessment. I've never seen the IDE, and it was not fun. So don't make that same mistake I did, and really know your space, right? So this is how most coding online assessment IDE will be set up, right? So first you have your top corner, which allow you to change your language. You get to go in with any language you're comfortable with. Please pick one language you're comfortable with. Don't switch it up. There's no point of switching it up. There's no like, oh yeah, they want to see this in C++. That doesn't exist. It's really what you're most comfortable with. It legit has everything. Even language I've never heard of before. Never heard of this, never heard of this, know this, don't know this, don't know this, don't heard of this, don't know it really. I know heard of this, never used it. Heard of this, never used it. Heard of it, never used it. Heard of it, never used it. XYZ, right? So you can see there's a lot, right? So you have your C, your C++, your really common ones. You have Java, you have Haskell, you have PHP, you have Perl, you have TypeScript. You have like a lot of options. One of the most popular one is Python 3. So I'm going to select Python 3 because I teach in Python 3 generally, and also take these in Python 3 because there's a lot more tools out there, right? So that allows you to pick your language. So this allows you to reset your code in question, right? So if you think you've gotten to a place, I rarely would use this, but if you think you've somehow gotten yourself stuck in a situation, you need to start from anew, set this, hit confirm, start from anew. So here are the description. What is really key is first thing you always do, at least for me, is I read this description. This description is what legitimately will make or break you, as in like if you somehow chooses to solve this problem and you don't do it exactly like how this description said. So even if you're off, right, let's say you misunderstood a concept in this description, you will not be getting any points. So I'm actually going to disable some stuff, and actually I'm going to do this. And hide this for a second, solely because you guys couldn't see everything. So there are test cases that they run. So they usually have a few test cases. They show you what they are passing in. So this is your test center. Then they also have generally lock test cases. You don't see it here. Well, you do. So some you actually see the lock, but you can see this is hidden, right? So they will only show you generally around like 3 to 5 test cases, and then the rest will be just hidden. So you can see from test 7 onward, it's hidden, so they won't tell you what they're running, but they'll run it and tell you the results. You can also build your custom test cases. So as you are designing your code, you can think of what tests might be out there. These don't generally all exist. This is because this is not actually part of the assessment. So like you get your solution, your README, and all that. This generally doesn't exist. This does exist, the setting and just the description. And then I'm gonna go back to my draft. So then you would just go along and code this out and just be like, hello, hello, and la la la, right? So after you're all done, you would just hit, right? You can run a custom test if you like, but you would just hit submit to submit the actual question, run test to run your test, right? So for example, this is what, write a function that returns the sum of 2 numbers. I hope I can do this. So I can just do return, and I can legit do like coding. During coding challenges is not class. Sometimes I know in class your professor might say you're not allowed to use X, Y, and Z during coding challenge. Those are all out the window. I can legit just use sum, and then I can just sum up param 1. I can't see, it's so tiny on my screen. And like param 2. This might not work because I forgot how sum works. I generally just write a plus out, but let's see. You can just run test, right? So this may, oh, no test work. You cannot run time error. And you can actually go to result to see what the time error is. It's not editable. Perfect. So all I can do is I can just put this into a list, give them a tuple if I really wanted to. Just need the editable object, and then you just run it, right? So you can see as it runs, it tells you what the task passed, and then these are locked, so they don't run them until maybe I hit submit. So I'm going to submit this code. It passed all 12. It gave me something. It tells me I unlocked a badge. This is only because it's not actually doing a coding a second version. It does all that. and then you just hit like continue and go to the next one, right? So that was CodeSignal. Here's another really popular one, which is HackerRank. So for example, HackerRank, you also get this. So this is the key important thing. You read through all this, figure out what your assignment you're doing, go through the constraint, your sample input, sample output, go through all of that. It also has the same thing as in test cases. So if I hit run code, I'll run the code, it'll tell me all my test cases and go from there, right? So actually, I'm gonna go back real quick. Actually, I can't, but yeah. So you can see your test cases. Again, you can choose all your different languages up here. You can reset your thing here. I would generally do this. This will like take it so you can only see this like in this format. You can also go back and see this coding format, and then it's same type of thing, right? So now let's go over some of the rules generally. There are rules when you're taking coding assessments, and this is the practice version. We'll actually take this later tonight during our actual coding portion, which like they give a duration, right? So this is an hour and 10 minutes, 4 questions. A lot of CodeSignal exams will be, this is on CodeSignal, you choose your language you prefer ahead of time. You submit each time. So I'm going to say Python 3. So you get an hour and 10 minutes for your whole exam. You have 4 questions. That averages out to around 15 minutes, almost 20 minutes a question. So keep that in mind. Hit next. They'll give you a few things that you have to pledge to and basically confirm you won't cheat. You won't do anything that's not allowed. And then you move on, you take the assessment. Then you end up in like what we saw earlier, and you're allowed to take the assessment. Here is the HackerRank version of that same thing. This is like a sample test. They will ask you a few things to tell you a bit about the test. They ask you for confirmation email, a declaration statement that you're not going to cheat, and then you go from there. So that is that. I can't remember what's next on the best coding practice interviews. So two things. First is always pick a language. Do not flip-flop between languages. Just pick one that you're most comfortable with, and that's the language you want to stick with. Do not in the middle of the thing go, okay, I want to switch to C++, or I want to switch to Haskell. Stick with that one language you decided on and continue it out. So pick your one coding language that you're going to use for all your generally coding interviews and go from there. Why? That's not Python. That's Python. Okay, cool. So that is one thing. Always read the description. I would even read this multiple times to make sure you fully understand it. Make sure you look at your test output, right? So I would read this and be like, give me 1 grand today. So 6 and 4. So inputs, it takes first the string, read all your inputs, read all your constraints, and then, okay, so this is 6 words. Okay, this is 4 words. Okay, so the first 2-letter type number word there is. So I'm matching these, right? So give, me doesn't exist, but 1 does. Grand, today. So it looks like you're just going through this list, the string, and looking to see if each word matches, right? And then you print out if it does or not. So your key thing is the second string has to be an exact subset of the first string. Okay, cool. Go to the next sample, like test your theory. Okay, so 2 times 2 is technically in there, but it only occurs once. Okay, so you have to keep track of the number of time of words in there too. It's like this says no, right? Which means like 2 is definitely in here. It was in here once, so you can't be in there twice. Okay, so keep that in mind. Think of how you would want to address that. So 2 times 2 is 4. Is and 4 is just 2 that threw us off. Explanation: 2 only occurs once in the actual magazine program, whatever the first one, right? And then same thing here. I've got some doesn't even occur at all. So things that doesn't occur will occur more than the amount of time the first string is. You discard. So you have your magazine, your notes. So the first string is they're calling it your magazine array, and then the second string they're calling your notes array. So you just analyze the problem like that. And then what I would start is write your code here. I wouldn't start writing code. I would first write out what you think we need to do, right? So for example, I might say, go through first, clean up the magazine string. Then probably like break it out into a list. We didn't miss much, so we're really going over. So this is our interviewing prep. Interviewing prep track part 2. So we just went over some basics of common IDEs. We went over some interview methods. Most notably, technique is the STAR technique. we're now going over what an interview, let's say coding ID would look like. Now we're going over some best practices in it, right? So we just went over. So first thing to do is pick one language you stick with, know your IDE. So like explore these beforehand time. They always come with practice exams. So make sure you spend time and take these practice exams. The two platforms we're looking at is CodeSignal, HackerRank. These are two of the most common I've seen. You have also seen people just give you a Word doc or make their own custom platforms. Now we're going over, so after you read and really understand the problem, make sure you do read it twice. Spend like 2-3 minutes just solo understanding the problem. After you've done that, it's starting doing some pseudocode instead of real code. So break it out into a list, right? Then let's say go through, do the same for the second string, and then like go through the second string and remove as you find it in the first. All right, so like that way we handle you can't have both, it has to be in it. If found something in second but not first, return no, else true, or else yes, right? I kind of put some pseudocode in there, so I make sure I truly understand the problem, run this code through those examples, and then start actually coding itself. Another thing is these are different per platform. You make sure you read the rules, and they're also different sometimes per company. So some companies allow you to work in your natural ID, so they allow you to copy out the problem. Not even copy out the problem, they allow you to copy out generally not the actual problem question, but you can copy out maybe your starter code if there's any. You can always work on this. Sometimes you really have to read this, the description and the fine print, but some will allow you to work not on these IDEs, outside of these IDEs, and then copy and paste the code back in these IDEs. Some will allow you to say what you can search on the website when you can't. So not all searching is disallowed. So some of these coding challenges would say, let's say you can look up things on, let's say, references or documentation. So if you work in Python, you might be able to look up the Python documentation. You cannot look up anything that's someone else's help or someone else's work. So like no Stack Overflow, nothing along those lines. I just realized I didn't go back to this mode. But yeah, if you have any questions, feel free to stop me and ask in chat as we move along. I think we're going to go back to here, which is time complexity. So there was some interest in doing some time complexity problems. I thought we would do some of that. So let me get set up for that. Let's see. So you might have seen some of this stuff. So we're gonna first bring up one of my favorite tools. I don't know which screen they're off. It came on the right screen. I'm gonna actually take this off screen for a second. Prep for it. Give me 1 second. Hold on. Actually, whoop. We're gonna blow this up. Okay, so I know it doesn't look great, but we do with what we have. So for example, time complexity is generally not a question you would get on an actual coding assessment interview. In terms of like you're gonna be coding it out. What you might get is, let's say your code is not optimal, and they might say, it's not optimal, please please optimize your code so it doesn't run in timer. So they might say all of the test cases has to run in 10 seconds or 20 seconds, and they might require you to fix those, but you don't have to actually understand time complexity. You just have to, you do to optimize your code, right? There are also during actual interviews in person, or when they talk to you live, or during your behavioral or technical behavioral, they might ask you such thing as like, here's some code, what is the time complexity of this? Or do you know what time complexity is, right? So like for time complexity, what I really do is do some practice to make sure you understand how time complexity is really calculated, right? So in our scenario, so this is essentially constant time, right? So anything that essentially is so minuscule that doesn't matter, it's just constant time. Oops, so that's not perfect. So for example, this would be technically constant time. So we're just gonna do it's big O of 1, which means constant time. This is also technically constant time, so we just don't worry about them. I'm bringing this out fully because you need to see this would be technically go off the screen. Okay, we'll use black. This would technically be right big O of n, because it's whatever n is the number of time we would do this. And then this a plus a is round. This is essentially also so minuscule it does not matter. So this will also just average out to constant time. So we're gonna say it's constant time. So that means this combined would be this doing this many time, which would technically just be big n plus 1, right? So this whole chunk will actually equate out to this, which then you can officially say that this is essentially just big O of n. And this is the same case right down here, which means that, so for this whole equation, you actually can write these into equations. So for this whole equation, you would get the big O of this problem, but the time complexity would technically be big O of 1 plus big O of 1 plus the big O of n plus 1 for this loop plus the big O of m plus 1. All right, so we gave all these time classes from to an equation. So from here, you can remove things that are non-notable. For example, this doesn't matter anymore because they're so non-notable. They're so maybe non-notable isn't the word for it. They're so minuscule, they don't matter to your actual final time complexity. You really just need the highest term in your time complexity. So for this, the one really doesn't matter anymore. We can take them out. So what this time complexity is just big O of n plus the big O of m, which you can just write that as big O of n plus m. Right, so that's the time complexity. Just however many times you need to go through this, however many times you need to go through this, and that's it, right? So this also just equates out to, it's essentially linear time complexity. I think. I don't remember my terms. I'm pretty sure it's linear. Let me look this up real quick. I don't want to be wrong. Time complexity. There's so many of them. So actually, let's go over the different types of time complexity too real quick. I just want to make sure I am not wrong. So let's see. I want ones that they actually say what they are. I mean, I know the time complexity. Okay, so I am right. Okay, cool. So I'm gonna pull this up on stream too. So these are all your terms for time complexity. So constant time complexity is what I said is big O of 1. Logarithmic time complexity, which is essentially exponential growth or actually decay in the amount of items you're working on, right? So so constant time would be like, it's so minuscule, it doesn't matter. You do it once, it's done. Logarithmic time would be, n is, let's say, a set of things. So logarithmic time is you don't go through the full entire set of things. So n essentially, linear time essentially saying you're going through, so if I had the list of 20 things, I'm going through it 20 times. While I touch every item in the list. Logarithmic time would, let's say I touch half the item on the list. That'll be log time. Then you have log linear time, which is a mix of those. So it's not log, it's also not linear, it's in between. Quadratic time, which would be insane. Quadratic time essentially is if you draw out your quadratic and plot it, essentially it's growing each time. So let's say if I am doing a recursive problem and the problem every time it splits, I have to do it 4 more times. That's most likely quadratic, and they have cubic, and it just keeps growing, right? So you can do math to figure out all of these. I'm not a big fan of math, so I'm not going to do them right now, but we'll go with some other problems. But then you have exponential time. So to be honest, your code is non-efficient the second you hit this time. Anything being down here is like your code is just bad. You want to generally stay in this range, but this range is okay, but you really should never be in this range. This range is more used in like academia to explain stuff than like actual like efficiency of your code. Should really never be quadratic, cubic, or exponential time. So there's actually some really good graphs and stuff like this. Let me pull one. Oh, there we go. So for example, the number based on the number of elements, here's a big complexity chart, right? So for example, you can see that this is the golden, this is okay, this is like as bad as we want to get, and this is just like no. Like you do not want to be in this time complexity range. And being honest with you, if you're ever in this time complexity range where your coding assesses, most of the time it will not pass all your test cases. But that does not mean if this is the only solution you know, you don't put it down, you do. So if you to make this really obvious, this is legitimately just writing 2 for loops, going through, let's say, n, going through n for both for loop, you have reached exponential time. So like this is actually really common to see. That's why you need to understand better solutions to try to keep it in this time range. But that's enough pain of that. Let's grab a second problem. Let's see. And let's blow this up. What's this out? Okay. Cool, so let's break down this problem. Some of you might see this. I find these problems online sometimes. So this would be, again, constant time complexity. So just 1. This way you guys can always, you might find these online. Prior range of this. So we're going to say n is our list of everything. So this takes, go for I in range of n mod by 2 to n. So this goes to like half of n, right, essentially. We don't have to be precise. This is really just half a guessing game. I think it's Sandra, but I can be wrong. I'm really bad at names. But welcome to the stream. We're doing technical interview prep, part 2, basics. So we're going go over time complexity right now. We went over some coding interview IDs, best practices. Feel free to ask me anything in chat as we're going along. We'll answer all of those as we go. Anything from experience questions to what we're talking about right now. We'll take a pause and answer them. Also going over the STAR interview technique, some behavior interview stuff, and now we're just again do some time complexity problems. Okay, so yeah, so for I in range of, let's say this, so it's half of it. So that's assuming, so it takes like another, then it goes, it's a second for loop, and then it goes for j in range of 2n pow. So that also doesn't go through anything. So let's say that goes through. Approximating these are fine because you don't have to show actual full math for it. So for example, that's at 2. It jumps by the power of 2 to the j. We don't know what j is this, okay? And then it goes to n. So this is, let's say, it doesn't go through the whole thing as well. So let's just call it half. So you can, if we're doing time complexity, you can definitely approximate because like small things like this will equate out to what the bigger problem is because you cut out certain components, right? This is like minuscule, so this is big O of 1 again. So like this is half, but you use 2 for loops, right? So it's half and a half. So you would start off with this, let's say this, plus let's say big O of 1 again, plus this first for loop will cause it to be technically n squared initially, right? Because like you do 4 loops, but because you see how you don't go through everything in the for loop, this wouldn't be completely n squared. Yes, there will be a recording of this later. So this won't be a complete n square. So I'm really doing this in a way that you don't do a math. People love math. There's a math way to do this, and that's perfectly fine, right? I'm doing an approximate way that everyone can generally learn and do this pretty quick, right? So you know this would normally be n squared because you use 2 for loops. And they're nested with each other, but they don't go through everything. So that you can see how much they go through. So the 2 options, if they don't go through everything, is this is either so is this n? This is definitely not linear. It doesn't go through everything once. You don't do squared because it doesn't go through twice. So it kind of goes through some things half of the time. So I would do n, let's say log n, right? So log n is, so how the order goes from before again is you have this, then you have big O of log n, which is better, right? Because it doesn't go through all of n. So you kind of don't go through everything, but you go through it twice. So it goes through n log n times. And it's a really easy way to do it because you know it can't be this, it can't be this, it can't be this complexity because you don't go through everything. So it has to be the one in between these two, right? This is not the mathematical way to do it. maybe one day we can do the math for it, but teaching math is not my favorite subject. Okay, cool. So let's do another time complexity problem that would be a bit better. Let's see. Actually, no. Let's see what's next on our agenda. So time complexity. Oh, just question. Okay, cool. So is there any questions that we want to explore, answer? So any question about the coding interview process, about just anything we've gone over? We'll take those now. If not, I was hoping this would go a bit longer. If not, we will be back tonight at 8 p.m. EST. And we're actually going to be taking a coding and practice assessment together. Live on stream. I'm really bad at this because I haven't had to do this in a while, but we'll be doing it for our stream sake. Any questions, comments, concerns I can address? Anyone has anything? Here, we'll put on the Ask Me Anything banner. I love this banner. Feel free to ask anything. Here's a star thing we went over. We did some practice questions. We did some exploring the coding interview IDE. We did some best coding interview practices. We did some time complexity stuff. Feel free to ask me any questions. I think I might bring up a guest next time. Maybe. For my next Global Hack Week stream, maybe I'll work out and we can bring up a guest and we can do like maybe coding golf. That sounds fun. No, it does not. I hate coding golf. Maybe we do that. But yeah. Any questions? If not, we might end this stream a bit early. And then we'll see you tonight at 2. But before we do any of that, remember that Global Hack Week is this whole entire week. And will be the next thing that came. Whoa. I definitely fixed this. Who changed this? Wait. I think someone else is using my same thing because I definitely fixed this. Let's see. There will be the stream that comes up next would be Mobile Development Track Part 3 from Zhang, one of our amazing coaches. I'm going to update this so it reflects it properly. So it's our Part 3 of our Mobile Development Track. If you have any questions about Global Hack Week, about anything we went over, feel free to let me know. Let's see. So we'll be with Zhang. It's going to be at 5 p.m. EST, right? No, it's going to be at... Yes, it will be at 5 p.m. EST. So make sure to stick around for that. If you have any questions, feel free to reach out. Actually, why not? Why don't we, as we kill some time, let's do some coding practice questions now, live. In terms of, let's see what I can do. So like another great thing about, well, let's do the hacker rank. Well, we'll do that tonight. Actually, no, we'll go through it. So for example, you go through instructions, you do all this, you agree, you do something right. So I can do like that, let them start. Then it would be, here's some testing questions. Yeah, we'll do this. This is the last thing we'll probably do today though, for right now, and then we'll be back for part 3 later. So finding numbers, all right, so you get the problem you solve, and then sometimes they have autocomplete ready. I like dark mode, so I always go to dark mode. So for example, you read the problem first, right? So you can do, given unsorted array of n elements, find if element k is present in the array or not. To complete the find numbers function and edit it below, it has 2 parameters. So an array of integers, so it gives you array, an integer k, that then says the element to be searched, and then you return a string yes or no, saying if it's present or not, right? So you always want to go through the whole thing, go through the whole example before you do anything. The first line contains integer n, outputs, right? So click, 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 it gets here's a sample array, and then answers yes. Wait. First line contains the integer n, each line contains an identity number of elements in the array. Next that contains each line. Okay, cool. So first it says 5 elements in the array. Then it says 1, 2, 3, 4, 5. And it says it's 1 in the array. Okay, cool. Got it. Yes. So this one is saying 3. So 2, 3, 1 is 5 in the array. No. Okay, cool. So first thing, we just write some pseudocode. Remember, we don't always start. We chose the language Python. We're going to stick in Python. And then let's write some pseudocode like Apple. I'm just kidding. So for example, we're first going to say, look let's look through array to see if k is in it. If k is in it, return yes. If k is not in it, return no. I'm really bad at this, so don't mind me. I'm gonna do this in an odd way. You don't have to do it this way, right? So first thing first is I'm gonna do. I think this is how this would work. So you can name anything, whatever, but make sure it kind of makes sense to you. So I'm just gonna use temp. Temp is equal to k in array. With Python that works, and then we're gonna do if temp return the string yes, else return no. I think this works. I have absolutely no clue. Run test, right? So test compile successfully. Oh, they want caps. Okay. Yes, and then do let's say no. Run all test. So we passed our test, right? So this is a great example of how, okay, so this is so simple. Time complexity doesn't matter, but watch. I'm going to do this on purpose. So I'm going to add in, let's say, if, so let's look at test case, let's say 3, right? So has a 3 in it. If, it's looking for 5, if k is equal to 5, well, let's do while. Okay, this you should never do this in your actual code. This is just me showing you what I would sum out about time. So I'd say right here, if I do k is equal to 5, and then we just do, let's do print, ha ha ha. So the point of showing this is, if I run this now, it should time out because it's going to hit that infinite loop. And when it's in the infinite loop, you can see why time complexity matters. Wait, what? Oh, I didn't break for more than one of them. So let's just do while. All true. We'll just do a simple one. Test. It's going to say it took too long. Okay, maybe I can't outsmart this as I think I can. But essentially, sometimes your solution is too slow. So for example, if I use instead of doing this, right? So maybe if I do for I in, let's say, array, and I do for I in array if I is equal to k. I should have just done this. This will definitely break it. But if I is equal to k, let's do temp is equal to true. I'm gonna first make true. True is equal to, temp is equal to false. Okay, so if I run this now, it should pass some of the cases and then not pass some of them. Because there's way too much object and too little time to go through each object. See, so time limit exceeded. So this only has 10 seconds for running it. So this is inefficient, right? My other solution is way more efficient. Then you would just submit the code, so on and so forth. You have 24 minutes left. La 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 la. We'll do some of the rest of this during later tonight's stream. I hope everyone had learned something from this stream, had a great time. And again, I want to remind you to make sure you've checked in. And then we will be doing part 3 of this stream, which will be tonight at 8 p.m. EST, which will be doing actual technical coding practices. And then please make sure to come back and join Zhang at 5 p.m. EST for Mobile Development Track Part 3, where you'll continue to learn how to develop a mobile application. With that, have a great Global Hack Week, everyone. Take care. Stay safe. Get some rest.